All right, so in this section, 7.6, we're going to be learning an entirely new number system. So if you're a little bit struggling with like the why do I have to learn this stuff with the rational and the radical expressions, now you're going to even be more so wondering why, because this unit that we're about to cover is all about imaginary numbers, so numbers that literally don't exist. We're going to learn about the rules about these numbers, and it's one little section, but you will use this again in pre-calc and beyond, so it's important, but it is a little confusing, like, well, why am I doing this? And what you are really doing is trying to figure out like where things would cross the x-axis when they actually don't. So that's where the imaginary system comes from. So for this section, complex numbers, we're going to start with just learning the imaginary unit, and you have to just memorize these two things. With these two things, you'll be able to simplify every expression that is considered to be non-real, which is imaginary. So these two things are super important. The square root of -1 does not exist in the real number system. If we took the square root of any negative number, like this here, this like little warm-up problem is asking us to use our calculator to figure out which one results in the error. We already know the error is going to be this one. This one's not going to work because the square root of -121 doesn't exist in the real number system. And our calculators only deal with the real number system. They don't deal with imaginary numbers. So somebody came up with a whole nother number system for numbers that don't exist in the real number system, and it's the imaginary number system. And in this system, the square root of -1 does exist, and it equals I, which stands for imaginary. So you can take the square root of -1 in this system. You can't use your calculator to get the answer, though. Another thing that's important to know is that when you take I and you square it, it really equals -1 in the real number system. So I squared is the same thing as -1, and I is the same thing as the square root of -1. And if you want to take a minute to explain why the square root of -121 doesn't work in your own words, in the real number system, when you take the square root of a negative, why doesn't that work? Take a minute to write that down.
What was the question?
Sorry, my question, I feel like I asked that kind of weird. I'm basically asking you to right here explain why the square root of 121, the square root, sorry, of -121 will give you an error. Why we can't do that in the real number system. Does anyone want to explain why we can't take the square root of -121? When we're square rooting a number, what are we doing? Yeah, we're basically breaking it up so that we multiply the same number by itself. Why can we never have the same number multiplied by itself to equal -121? Annika? Right. And a positive times positive is a positive. In order for us to get a -121, they have to be opposite numbers, which is not what a square root allows. So in your own words, kind of write that out, and then we'll really get into it. So before this section, if we ever got a question like this first one here, the square root of -36, we would have absolutely said this is not real. It doesn't exist. You get an error message when you go to put that in your calculator. But now, if you see a question like that, that answer is not the correct answer. Now that we're going to be learning this new number system, if this comes up on your next web assignment, which it will, or your next test, you're not going to write it's non-real anymore. What we're going to do is simplify this using the imaginary number system. So showing your work is helpful in the beginning, but as you like learn it, you might be able to skip some steps, but I'm going to show all the work just so that we're sure we understand the process. So the square root of -36. What we're going to be doing is taking these square root expressions and we're going to be simplifying using the definition up here. What this definition says basically is what you can do is split up the number into the positive version of that radicand. So positive 36 times -1. So we can break it up so that we can write it into this new form, which is the imaginary number form. Technically, the square root of 36 times -1 is the same thing as the square root of 36 times the square root of -1. Do you have to show that work? No, I'm just showing it to you now so you can really see it. Once you then break it up, you can see that the square root of 36, we can simplify to just be 6. And the square root of -1, we learned from the top of the notes, the square root of -1 is equal to I. So the square root of -36 is the same thing as 6i. I is like a variable, but the variable really represents that it's an imaginary number. So when I write my i's, I don't know why, but I like make this little curved I because I feel like a lot of times they do that. They use like italics when they talk about imaginary numbers, but it's just 6i. For the second one, you're really just trying to rewrite both of these expressions in imaginary number form first, and then simplify what you can. So 48 is not a perfect square in itself. So I'm not going to just rewrite it as 48 times -1. I'm going to rewrite it as 16 times 3 times -1. Because I want to still be able to reduce this, even though it's not a perfect square. I can break it up into 16 times 3, which is a perfect square. Well, 16 is a perfect square. And then for the denominator, I'm going to rewrite that as 3 times -1. You don't have to show the step where you break each one up unless you really want to. If you can see from here, the square root of 16 is going to come outside of the radical and become a 4. The square root of 3 is going to remain the square root of 3. There's nothing I can do with that. And then the square root of -1 really equals I. So the numerator becomes 4 times the square root of 3 times I. And then the denominator, the square root of 3 will remain the square root of 3. That square root of -1 turns into an I on the outside. And then you simplify this once you have it in imaginary number form. So the format is that if you have a plain number, that comes first. If you have a radical, that comes second. And then the I always comes last. So on WebAssign, you're going to have to make sure it's in that correct order or it will mark it wrong. Regular number, square root, I. But in this case, the square roots actually will end up still canceling out like they would normally in a regular fraction. And so do the I's. So this answer ends up just being 4. In the imaginary number world. So go ahead and try the 2 checkpoint questions.
Yeah.
Let's see. All right, so -54, I'm going to break that up. 54 is not a perfect square, so I'm going to break that up into 9 times 6, and then times -1 as well. The square root of 9, I can take out of the radical, and the square root of -1, I can take out and turn that into I. So the square root of 9 is 3, the square root of 6 still remains, and the square root of -1 is I. This is the correct format. So regular number first, radical in the middle, and then imaginary I at the end. For number 2, this is the square root of a negative fraction. If you can kind of see it and you can get the answer right in one step, that's fine. If you wanted to break this up and really show that you're basically taking the square root of 16 over the square root of 25, multiplying that all by the square root of -1, you can kind of break it up this way. You're basically going to square root the numerator number, the denominator number, and then attach the I to the end of it. So the square root of 16 is 4, the square root of 25 is 5, and then the square root of -1 is I. So 4/5 I. The first 6 web assigned questions are simple little simplify these imaginary number radicals. So that's why there's so many questions, but it's really not that bad to start. But of course, we're going to start with simplifying these types of problems, going through operations with them. And one thing that's super important about this is anytime you have an imaginary number, so you have to be able to identify it. Anytime you have the square root, which will really only be dealing with square roots. There's no other roots we're dealing with for this section. For square roots of negatives, anytime you see a negative inside of that square root, that radicand, you have to really make sure you're following these directions. So the directions say, to perform any operations with square roots, simplifying anything, you have to first write the numbers in I form. So before you do anything, like before in letter A, we add anything, which we can anyway because they're different radicands. And in B, before we multiply, you have to put everything in the imaginary form first, and then you follow the directions, whether it's add, multiply, whatever. So for the first one, I know that we're adding radicals. The same process still applies. We can't add radicals that don't have the same radicand, but looking at the radicands, they're negative. So we have to put them in I form first. The square root of -9 is the same thing as 3I. If you can see it and you don't need to show all the work, then just say that it's 3I. If you're like, wait, where did you get that from? Then take the time to do the steps until you can really see it. This is the same thing as 9 times -1. The square root of 9 is 3. The square root of -1 is I. And then we have plus the square root of -49, which is the same thing as 49 times -1. The square root of 49 is 7. The square root of -1 is I. Once you put it into imaginary number form, then you can add them together. So the i's stand like, regular variables. You have 3i plus 7i, you have 10i. So you still follow the same process as before. For letter B, as soon as we see multiplication, we already know we can multiply anything by any other number. Doesn't matter what type it is. But for this section, you can't multiply right away. You have to put both of the things in I form first before you can perform any operations. So 15 doesn't have any perfect square factors. So the only thing we can do here for this one is just rewrite this as the square root of 15i. Times, this is the same exact thing, so it's going to be another square root of 15i. Okay, and then once I do that, then it's time for me to multiply. Now that everything is in imaginary number form, I form, then I can multiply. So when I'm multiplying these things, I multiply the radicals times the radicals. The square root of 15 times the square root of 15 is just going to be 15. And then I times I is I squared. Now there's a thing that I start at the very top of our notes that we actually haven't seen yet. We saw already at the top of our notes that the square root of -1 equals I, but the second thing we haven't used yet is that I squared equals -1 in the real number system. So 15I squared can actually be simplified further because the second part to this system is that any I squared really equals -1. So this is really 15 times -1, which equals -15 in the imaginary number system, which makes sense kind of. If you look at the problem, we already learned that if you have the square root of a number times the square root of that same number, it cancels out and you're left with the radicand. Now, does the square root of negative 15 even make sense though? No, it doesn't exist in the real number system, but it ends up still equaling the same thing. It just goes through a different process. Go ahead and try the 2 checkpoint questions. Lesson. All right, so as we're learning this and practicing, really showing all the little steps is, I think, helpful so that we don't lose track of anything that's going on. So I'm going to show all those steps, but as you get through it, if you're like, this is making sense, I can skip some steps, that's fine too. So for these problems, first thing I'm going to do when I notice that they're negatives inside the radicals, I'm going to separate them into perfect squares times whatever factors times -1. So 32, I can rewrite that as 16 times 2 times -1. All right, minus 2. And then I'm just going to rewrite the 2 times -1, just so I can really see what's going on here. So then I simplify. The square root of 16 is 4. The square root of 2 remains the square root of 2. And the square root of -1 is I. So that first term turns into that. And then minus the 2 inside the radical stays there because that's not a perfect square. I'm just going to make that minus 2 square root of 2i. You can combine like terms if they all have the same components. The first number, the regular like coefficient regular numbers, can be different. But as long as they have the same exact radical and they both have an I, you can combine like terms. So you have 4 of these square root of 2i's minus 2 of them, then you have 2 of them left over. So that would be your final answer in the correct order. Regular number, square root of 2, and then I. For number 2, before you do any multiplication, anytime you have these imaginary numbers in square root form, you have to convert them to imaginary number form first. So the square root of -5 is really just going to be the square root of 5i times the square root of negative 45. I don't like to do too many things at once. I could do that at once, but I really do like rewriting this as 9 times 5 times negative 1. And then minus, I'm just going to rewrite the 4 as 4 times negative 1. Just so I don't forget anything. Then rewriting that, simplifying what we have so far. The square root of 9 is 3. The square root of 5 stays the square root of 5, and then I can take the square root of negative 1 and turn it into I. Minus the square root of 4 is 2, and the square root, this is a negative 1. The square root of negative 1 is I. So once I have everything in I form, now it's time for me to perform the operation. Looking at what I see here, the parentheses means that I'm going to have to multiply this outside number by everything inside. I can see the inside things are not like terms, so I can't combine them right now, so I have to distribute. And when I distribute, you multiply regular numbers by regular numbers, radicals by radicals, I by I. So the square root of 5 times the square root of 5, I'm going to be able to multiply those together. This one is just like 1 square root of 5, so the 1 gets multiplied by the 3, so I should start with that. 1 times 3 is 3, so I'm going to have a regular 3 on the outside. The square root of 5 times the square root of 5, I'm sure you already know this, it's going to just equal 5, but I'm going to show you that you can still use the same rules as before. You can multiply the radicands together. The square root of 5 times the square root of 5 is the square root of 25, and then I times I is I squared. I'm going to simplify that later, but here's what I get when I multiply the first terms. And then when I multiply this by the second term, this is going to be 1 square root of 5 times 2i. Well, 1 times 2, that's going to be minus 2, the square root of 5, and then I times I is I squared. Okay, then I simplify what I have. This is going to be 3 times the square root of 25 is 5, and I squared is negative 1. So I have 3 times 5 times negative 1, so my first term ends up equaling negative 15. Minus, nothing really I can do here, 2 times square root of 5, that's just, it is what it is, but the negative 1, or sorry, the I squared can be rewritten as negative 1. So minus a negative, only thing I can do is turn this into a plus. It's going to be negative 15 plus 2 root 5 as your final answer. So the format of your final answers, if it has an I in it, the I is always last. If it has a radical in it, the radical is always last. If it has a radical and an I, the radical would come first before the I. The I is definitely always last. So this format, this would be like how you would insert it into WebAssign. If you put it in the opposite way, they would mark it wrong because of the way that they program the questions. Okay. So now moving on to complex numbers. So a complex number is the number of the form a plus bi, where a and b are both real numbers. And then a is the real part of the complex number, and then the bi is the imaginary part. So a complex number would allow us to have a real number in the answer and also an imaginary number. I feel like this is like a hard problem to start with, but let's figure it out. So example 3 is asking us to find the values of x and y to make this a true statement. So what we have here is 3x minus the square root of negative 25 equals 6 plus 3yi. I feel like this is a perfect SAT question because it's kind of hard, but if you can figure it out, like knowing that these two things are equal and use your skills of solving equations, it's definitely doable. But looking at this straight away, it's kind of like concerning. But let's just take it step by step. We have two equal things. And first thing I want to do is simplify this here, the square root of negative 25, to see what that equals. So I can look at the equation in the same form. This equation has an I, so it's already an I form. This one doesn't, so let's rewrite this. So 3x minus the square root of negative 25, I'm going to rewrite that as 25 times negative 1. And just rewriting the rest of the equation is 6 plus 3yi. And simplifying this, the square root of 25 is 5. And the square root of negative 1 is I. So I can simplify this to 3x minus 5i equals 6 plus 3yi. The goal here is to find the values of X and Y to make this a true statement. X is easier to find than Y. Looking at X, I have here 3X, and this is my regular real number. On the right-hand side of the equal sign, that is the other real number, it's 6. What does X have to equal? 2. So this one's easy to see because 3 times 2 gives us 6. The equation that we could actually create, though, to really find it would be, how can we make 3x equal to 6? Because this is the real number and this is the real number. This is the imaginary number part. This is the imaginary number part. So to make this true, we know that x is going to equal 2. When x equals 2, these two numbers will be the same. All right. And then for the other part, we have to basically make negative 5i equal to 3yi, and we're solving this thing for y. We want to figure out what value of y will make this true. Well, we could divide both sides by I right now, and they'll cancel out. So really what we're trying to just do is figure out when negative 5 will equal 3y. Now, of course, it's not as easy as this one because just 3 times 2 is 6. But all we have to do is divide both sides by 3, and it should be negative 5/3. But when I'm solving things like this, I don't really I can't see it until I really put the answer in to be able to be confident, like, okay, this is the answer. So what I'm going to do is put these numbers back in and see if it actually works out, and we will see that it does. So when we multiply the 3 times the 2, we insert 2 in for x minus 5i here on that side. And then on the right-hand side, 6 plus 3 times, we found it to be negative 5/3 times I. Let's just make sure these two things are equal. Well, 3 times 2 is 6, so this side is 6 minus 5i. And then on the other side, 6. And then if I multiply 3 times negative 5/3, it's going to be just negative 5. So negative 5i, since those 3's cancel out. And that's equal. 6 minus 5i is the same thing as 6 plus negative 5i. So we're good. We found the two numbers that would have to be. And that's actually a good question, but kind of a hard one to start that next section with. The next one, the next example that we have here is operations with complex numbers, which is, again, still kind of the same thing as before, but now we're going to be dealing with answers that have a real number in it and also an imaginary number. All right, so for this example, first thing that we're going to do is multiply it out as long as everything is in imaginary number form. And just taking a look at the problem, I can already see there are no square roots of negative numbers, so we're good. We can start just using the operations. So this is going to require us to use the distributive property since the inside stuff, we don't have like terms here. So we multiply 5i times negative 2, multiply the 5 times the negative 2, that's negative 10, and then attach the I to it, that's negative 10i. And then we multiply the 5i times another I, and that's going to be 5i squared. Once we do that, we just have to remember the two rules that we have. The square root of negative 1 equals I, and I squared equals negative 1. We're going to be using that second rule here and replacing in a negative 1 in for I, and we get negative 10i minus 5. Technically, though, the answer needs to be flipped. So if this is how your answer came about when you solved the WebAssign question, you will have to switch the order and put negative 5 first, minus 10i, because that's the technical solution order. It's like the standard form for complex numbers. This is a complex number because this part right here, the first part is real and the second part is imaginary. A complex number has both a real component and an imaginary number, and you have to put it in this same exact order. All right, the next one is asking us to simplify 1 plus I squared. So we cannot use exponent rules in this part, in this problem, because of this plus sign. Anytime you have 2 things or 3 things, whatever it is, but you have multiple unlike terms, you have to multiply each thing, each component, as many times as the exponent says. So we have to rewrite this as 1 plus I times another 1 plus I. That requires us to FOIL, and we will get 4 terms that usually you can combine the middle two. When you only use exponent rules, you actually miss those 2 middle terms and they're needed for the multiplication. So when I'm multiplying this out, this is a regular 1 times another regular 1. That's just equal to 1 because that's a real number. We know that. But now we're going to multiply a real number times an imaginary number. 1 times I is I. Another I times 1 is another I here. And then this last I times I, that's I squared. I'm going to combine like terms. So I have 1 plus 2I, and I know that I squared equals -1. So this is the same thing as like plus -1 or -1, which means the ones end up canceling out, the 1 in the beginning and the 1 at the end, gone. And this is just going to be equal to 2I. So this is actually not a complex number because this is just an imaginary number, 2I. So what I want you to do is go ahead and try the 2 checkpoint questions. We'll go over those answers, and then we'll see where our time is. We'll use the rest of the period to get started on WebAssign.
Thanks.
All right, let's go over these to make sure we're good, and then we can stop here and start with example 5 tomorrow. So for the first one, we have to distribute this negative to everything behind it because it's minus the entire thing in parentheses here. So this is going to be 6, and it's going to end up being plus 2 minus 9I. And then because this plus sign is here, we don't have to distribute a positive 1 to everything. But when it's negative, you do have to distribute a negative to everything. So this is going to be plus -2 or just -2 and then plus I. Oops. All right, then combining like terms, I have 6 plus 2, which I can combine that together with, because they're regular numbers. So 8, and then this is a -2. So we have just 6, and then -9I. Plus 1I, that's going to be -8I. So this would be 6 minus 8I in the correct order. And then the next one, we have to FOIL this out. So 2 times -6 is -12. 2 times 2I, that's 4I. 3I times -6, that's -18I. And 3I times 2I, that's 6I squared. Then for the simplification, I can combine these two terms in the middle here. And that's going to be negative 14i. And then I squared really equals negative 1. So I'm going to insert a negative 1 in for I squared and then simplify that. So 6 times negative 1 is negative 6. So I can combine negative 12 with negative 6. That's negative 18. That comes first. Minus 14i would be your final answer.